Okay, so here's a vector equation. It's in 2D. There's just x and y components here, and it's kind of quite abstract and pure. And what we can do is we can make it a little bit more realistic. Rather than going straight to the answer, let's just have a visual on this and understand what this question actually means. I won't do this in an exam situation. I'm just trying to do this for kind of teaching and understanding purposes. But if we do this guy as blue, this guy is green, we just get an understanding of how this vector equation of the line works. So let's go back to blue. Nice light blue, okay. So there exists a particle, let's say, that's traveling according to this vector equation. And so this says we jump out to coordinates -3, 2 by going in a vector journey. So -3, 2. So we hop onto a point, and this point lies on this particular line. And then we travel with this direction vector a certain amount. And so that allows us to access any particular point on the line. So we have a little look, 2, -1. So that's 2, -1, 2, -1. And we kind of got the idea, 2, -1. It's not to scale, but here is the first line, right? And the green line's a similar thing. Again, I won't do this in an exam. I will just go straight to the exam solution for you. So the second one is jump out to coordinates -1, 6. -1, 6 is here. And then travel according to this direction vector. So that's -3 and 4. So -3, 4, maybe here. And of course, you can travel in either direction. And you can see there's going to be an intersection point, right? Because the gradients are different. Again, it's not to scale, but it's just an idea of how to interpret these two vector equations of lines. So let's just go to the exam solution. So the exam solution is quite simple, really. If we generate the parametric equations, so this is for the blue line, and then for the green line, okay, so I did the plus minus deliberately just to show you that obviously we can replace that with just the negative. Okay. Now let's just think about what this actually means. This means that for one of the lines, this is the x coordinate, and the other line, this is the x coordinate. Now clearly we need both x coordinates to be identical if the points are to be in the same location at the same time. So we go ahead and equate the two x coordinates, -3 plus 2s equals -1 minus 3t. And you've probably seen it then. We obviously equate the y coordinates, because obviously the y coordinates have to be the same if the two lines cross at the same point, right? So this point here has obviously the same x coordinates for both the green and the blue, and the same y coordinate for both the green and the blue. All right, so let's create a second equation. You can see where this is going, hopefully. 2 minus s is equal to 6 plus 4t. Okay. And clearly we could solve this by hand, but we also have a TI Inspire and the solve system of linear equations, right? And again, it might be quicker just by hand rather than typing all that into your system of linear equations, or it might be just quicker on the calculator. I'm going to do this by hand, so I'm going to times this bottom by 2, and I'll just supersede 4 here, -2s, 12 and 8, and then I'm going to add the two equations together. All right, so -3 plus 4 is 1. The s's cancel out. This is -1 plus 12 is 11. -3t plus 8t is 5t. And I can see now that the t here is equal to -2. And then if t is -2, I'll go ahead and substitute it in here. So -3 plus 2s equals -1 plus 6. That gives me 2s equals 5 plus 3 is 8. That gives me s equals to 4. All right. So once t equals 2 and s equals 4, we can go ahead and substitute it in. S equals to 4 here. But notice we could have actually stopped at t equals 2, because all we need to do now is sub t equals 2 into this parametric equation. All right. So t equals to -2 goes in here. Let's just confirm that both parametric equations with the t equals -2 and the s equals 4 give the correct answer. So let's go now for this equation. So I'll go back to green, right? So the green, x equals -1 minus 3t, and y equals to 6 plus 4t. So the x coordinate here equals -1 plus 6 is 5, and the y coordinate is 6 minus 8 is -2. So this is at 5, -2, according to the green. Let's confirm it with the blue. So over here, the x equals -3 plus 2 times by the s value, which was 4. And the y was equal to 2 minus 1 of the s, 2 minus 4. And again, you can see here that y equals to -2. And here x is equal to 5, all right? So look, 5, -2. So a quick summary then, no need to draw the graph. You can go straight to forming the parametric equations and solving. But when you solve for s and t, once you've got one of the answers coming out, the t, no need to sub back in to get the s, because you can see clearly that just the t value on its own will give us the coordinates of the point of intersection.